Hello friends, I'm Engineer Nasir. In this video, we will do a sample calculation to design the ventilation system for public toilet in a commercial building like mall and office, etc. For our sample calculation, we will use this drawing. These are two public toilets. This is for ladies and this one for gents. For this toilet, for exhaust air and fresh air, we will use the ducting. You can see this ducting to remove the exhaust air from the toilets, and this green line is ducting to supply the fresh air to the toilet. In this toilet, there is janitor room, then toilet 1, toilet 2, toilet 3, and this toilet for handicap. And this is the area outside the toilet. We call it passing area or salvage toilet also, where we have wash basin. For ladies toilet also there are toilet, janitor room and passing area. To calculate the exhaust air CFM, we will use this table from ASHRAE. In this table you can see for public toilet, for continuous operation of exhaust fan, we need 50 CFM for each toilet. The area outside the toilet, which we call salvage toilet or passing area. For passing area, we consider 1 CFM per square feet. If you have urinal also there, then for one urinal, take the exhaust air same as for 1 WC. Now based on the ASHRAE table, we will assign the exhaust air CFM to each area. For janitor, area equal to 40 square feet. So exhaust air required is 40 CFM. Then for one toilet, exhaust air is 50 CFM. And for passing area, we calculate the area here, which is 162 square feet. So exhaust air required here is, we can take in round figure equal to 160 CFM. Now we'll make an Excel table for this value. Here is the area name, then it is exhaust air required, and this is fresh air. Fresh air we take 80% of exhaust air. So for janitor we have area 40, and at the rate of 1 CFM per square feet, we need the exhaust air 40 CFM, and the fresh air value will be 80% of it, 32 CFM. For each toilet, we take exhaust air CFM 50 and the fresh air required for it will be 40 CFM. For passing area, the area is 162. So we will take the round figure. We need exhaust air CFM for this area 160 CFM, and the fresh air CFM value will be 128. So when we make sum up, the total exhaust air for this male toilet will be equal to 400 CFM, and the fresh air will be equal to 320 CFM. Similarly, for female toilet, the total exhaust air value will be 400 CFM and the total fresh air value will be 320. To select the exhaust air fan, we will add the exhaust air for both toilet. So it will be equal to 800 CFM. So we need to select a fan of 800 CFM for exhaust air. Similarly, for the fresh air, we need to select a fan equal to 640 CFM. For fresh air supply, normally we supply fresh air in area outside the toilet. You can see in this drawing, this is the fresh air duct, and we are supplying fresh air for the male toilet here, 320 CFM, which is 80% of the total exhaust air for this toilet. Similarly, in ladies toilet also, we are providing 320 CFM fresh air, which is also 80% of this toilet. Now we'll select the exhaust air duct size. You can see for janitor, exhaust air CFM is 40. So for this duct, CFM value will be 40. For one toilet, we have exhaust air is 50 CFM. So at this point of duct, the CFM will be 90. After addition one more toilet, the CFM at this point will be 140. At this point will be 350. In this table, we have mentioned the exhaust air CFM at each cross section of the duct. First cross section 40, then 90, 140, 300, 350, 400, then 450, and up to 800. Now we will select the duct size for exhaust air. At first cross section we have the CFM 40 and head loss 0.1. Then the duct size for the CFM will be equal to 4 by 4 inch. Then at next cross section we have the CFM value equal to 90, head loss 0.1. Then the duct size for the CFM will be equal to 6 by 4 inch. Similarly, we have selected the duct size for each cross section. You can see for CFM 40 4 by 4 inch, for 90 6 by 6 by 4. For CFM 140 we have the duct size 6 by 6 inch. For 300 by 8 inch. For 350 10 by 8 inch. For 400 size 10 by 8 inch. And up to for 800 CFM we have the main duct size 14 by 10 inch. Then we have two branches for the fascia having 320 CFM. So for the branch for fascia we need the size 10 by 8 inch, and for the main duct after two branch for fascia we need the size 12 by 10 inch. Now we'll select the diffuser size also. For toilet exhaust air we have 50 CFM. For passing area exhaust we have 160 CFM, and for fresh air supply diffuser we have 320 CFM. Now from this table we will select the square ceiling diffuser size. We have one CFM 50, another 160 for exhaust here. So we'll select from this range 6 by 6 inch, and for fresh air 320. So we will select from here this range 300 to 1200. So for fresh air we will select the diffuser size 15 by 15 inch. Now we will update these sizes in this drawing. For generator 40 CFM, so exhaust air duct size is 4 by 4 inch for 40 CFM. Then after this we add one toilet 50 CFM, and for 90 CFM the size is 6 by 4 inch. Then for 140 CFM 6 by 6 inch exhaust air duct size. We have one branch from passing area 160 CFM, duct size will be 8 by 6 inch. Then after this CFM will become 350, so the size will be 10 by 8 inch. Then here the CFM will be 400, exhaust air duct size will be 10 by 8 inch also. Then at this point the CFM will become 610, so duct size will be 12 by 10 inch. Then it will be same size. Here we have the CFM 760, the duct size will become 14 by 10 inch, and up to the end will be same 14 by 10 inch. For fresh air, for 320 CFM, the duct size is 10 by 8 inch. Here also 10 by 8 inch. Then at this portion, the CFM will be double 640. So the duct size will be 12 by 10 inch. Then for square ceiling diffuser for the toilet, for 50 CFM, it will be 6 by 6 inch. For 40 also will be the same. But for 160 CFM, the square ceiling diffuser also 6 by 6 inch, and for fresh air 320 CFM, the square ceiling diffuser size will be 15 by 15 inch.